So hello everyone. So here this is another question using Perceptron. So here question is for OR gate. In the last class we have done this for AND gate, and today we are going to discuss about OR gate. So here in the last class, in the last video, I have done the weight updation step by step. So here I am going to use another method. In one table we have to maintain a table, and so we can update the weights. So we see, let's how it is working. So in this question you have given two inputs. So before we start, we have to create the perceptron model first. So you see here, this is the model. Okay, so here two inputs are coming. Two inputs, one is x1 and another is x2. Okay, so another thing is here also or get dataset we have to prepare. So here or get dataset is important. So you know that or get having, if I take two input or get, you see this is x1 and x2. These are the two inputs, and y let is corresponding output. Okay, so this is the thing we have to maintain in a tabular format. So the OR gate dataset is, if I make the dataset OR gate dataset, it will be look like this. Okay, dataset. So here, what are the combination of x1 and x2? It's a binary type 0 0. Its output is 0 for OR gate. For 1 0 combination, 0 1 combination, it is going to produce 1. So basically in OR gate, if both inputs are 0, output is 0. Otherwise, it is 1. So for 1 0 it is 1, and for 1 1 it is also 1. So this is a simple, okay, this is simple OR gate data set. So here we are going to apply the perceptron algorithm in tabular format. No need to go to solve it step by step. So we see how can we apply here the perceptron algorithm. So first make the structure complete. This is the perceptron, single perceptron. So here we have to calculate the first summation value. Let's its name is Z. So what is Z? I already told you. These are the weights let. So W1 is given 0.6 and your W2 also given 0.6. Initially both are 0.6. So both x1 and x2 both initially 0.6. So you see here, so we have to calculate weighted sum value is equal to, I can write W1 x1 plus W2 x2. Okay. So we can we have to do the summation here directly. So let's start. After whatever result we are getting from here, that value is going to provide to the activation function. So here activation function is working, and here also threshold value is 1. Okay, so activation function is working. That means the activation function will produce output y cap, okay, 1 when. So I can write the activation function part. So your y is going to produce output how? By using the activation function. So it takes z as the input, and it is going to provide 1 if the z value greater than or equal to 1. It is given here in the threshold part. Threshold is 1, and in the second part it is going to provide 0 if the z value less than or equal to 1. Okay, so we have to use that to produce the predicted output. Okay, so here this is the model basically, and so let's start working on that. This is the input. 4 inputs are there. Okay, we have to provide one by one to predict the corresponding output. Let's start with the first input. The first input is, what is the first input? X1 equals 0, x2 equals 0. You can write here both 0. This is both are 0. Okay. Now the job is to find z value. Now what is z value? Z value is equal to W1, which is equal to 0.6 into 0 plus 0.6 into 0, which is equal to 0. So now the z value is 0. If z value is 0, then what is the how to find the predicted output using activation function? Activation function telling that if z value less than 1, it is going to be 0. So since 0 is less than 1, your output is going to be your 0. So here for this case you got the predicted output 0. So I can whatever values I am getting here, I can maintain in this tabular format, so better understand. Okay, so now here you see I can add some points here. One is initial weights W1, W2. Okay, I can add here. Okay, before every step, before we proceed every step, we can maintain in tabular form. So initially, what is the value of W1 and W2? You write initially 0 0.6, 0 0.6. Okay, for this case we are applying, and this is the W1 W2 present value, and again also you can maintain the table Z value. So what is the Z value? We can find using the formula. To find the Z value, you can use this formula. Okay. Now next part is you see Z value you have to write down here using this formula, and another maintain we have to maintain that predicted output Y cap. So predicted output also we can maintain. So another line, another column I want to add here, that is error. What is my error? Error is equal to Y minus Y cap, you know that. Okay, so this is the error. Okay, so E is the error. This thing also we want to maintain here. And after that, and what is Z? Z is equal to W1 X1 plus W2 X2. Okay, so here, and this is the error part. Okay, after that, how this error is going to help to predict, to change the weights or adjust the weights, we will see. So our first weight is W1. So remember that what is the weight updation formula. So the weight will update how, using this from W1 plus eta, this is the learning rate, and error and X1 input to change the value of W1. And how to update the value of W2? W2 is equal to, you can write here, W2 plus eta into error into X2. So we are going to use this formula here to update the weights. Okay, so you can write here all the things. So in one table we can maintain all the things. So here the W2. So okay, now this table is enough to compute for one epoch. Okay, so now you see, so initial value W1 W2 how much? 0 0.6, 0 0.6. Input X1 X2 given, its corresponding output is given, and what is the Z value? You calculate that using this formula. Z value is equal to W1. You directly also can count here. W value is equal to 0 0.6 into X1 0, that is 0, plus W2 X2 0 0.6 into 0, both are 0, so this value is going to be 0. Okay, then now how to find Y value? Using this formula. How to find predicted output? Using activation function. If this Z value greater than 1, then output is going to be 1. So since it is less than 1, so this is output also going to be what? 0. So here we got 0. And what is the error here? Both real output and predicted output, both are same. So error, if I do the minus 0, that is 0. So here no need to change the weights. So weight is going to remain same. So no need to update the weights, because this weight predicting perfectly. So it is going to remain the same. Okay, now go to the second sample. This is the second sample. Okay, before you proceed, you add these weights here, because in every step the weights of previous step is going to use in the next step. So you use here. So here you add 0.6 and 0.6. Okay, now you process the same thing. So here you see now X2 equal to 1 and your X1 equal to 0, and you do the calculation. So directly we can do here 0.6 into 0, that is 0, plus 0.6 into 1, that is 0.6. So here Z value is going to 0.6. Directly you can do, just do multiply and sum, you are going to get 0.6. Okay, now how to get Y value? You already told you predicted value Y cap. If this Z value greater than 1 because threshold is 1, but it is less than 1, so predicted output is going to be 0. Okay, your predicted output is going to be 0. Now what is the error? You see here in the data set, what is the real output? The real output is 1 and your predicted output is 0. So your error is equal to 1 minus 0. This is 1 minus 0, that is 1. So you got error 1. Now you have to update the words. How to update the words? Using this two line. Okay, now let's start to update the word for W1. W1 is equal to W1 plus means this one W1 0.6 plus eta, that is 0.5 into error 1 into input x1. What is x1? 0. So that means 0.6 plus this whole part is going to be 0. 0 multiply means 0. So here I am getting 0.6. So let me write the new weight 0.6 here. In the same manner, if I proceed, this is also I can proceed here like that. Here my weight is this is what 0.6 plus learning rate 0.5 into error 1 into what is your input x2 1. So you can multiply 0.5 into 1 into 1 0.5 0.6, that is 1.1. If you do the summation, you will get 1.1. Okay, so now you got a new weight 1.1. Now so this weight this new weight now in the next round we have to use. So write down first 0.6 1.1. Okay, now let's use them. So now we have to take third sample, training sample. So now my x1 here is 1 and my x2 here 0. Okay, here directly you are going to use. So first job is to find the weighted sum. How to find the weighted sum? W1 into x1, that is 0.6 into 1, that is 0.6 plus 1.1 into 0, that is 0. That means 0.6 into plus 0, which is going to give me 0.6. Okay, directly do the summation. Now again this 0.6 is less than threshold. So that's why y cap is going to be what? 0. And what is the real output? 1. What is the predicted output? 0. So error is coming 1. So 1 minus 0 is equal to 1. So my error is coming. So that means we have to update the weights. So how to update the weights? Again use the formula. So here I am going to use W1 0.6. Okay, this is okay. Plus learning rate 0.5 into my error 1 into x1. What is the x1 value? 1. So here x1 value equal to 1. Okay. So if you do the calculation, 0.5 plus 0.6 is 1.1. So here W1 is going to be 1.1. Okay. Now let's go to W2. Using the same formula, W2 ka what is the value of W2? 0.1. Sorry, 1.1. You just change here. So your W2 is 1.1 plus 1.1 plus learning rate 0.5 into error 1, your error is 1, into your input. What is the input of x2? In 0. So this is 0 means this whole thing going to be 0. This is 0. So that means this W2 is going to be same. No change here. Okay. Now over. Now these new words we have to use for the next iteration. Okay. Now coming here. So here we can use this. Now 1.1. Okay. Now you take that. So now my x1 is 1, my x2 is also 1, both are 1. And what are the words I have now? My words are 1.1 and 1.1. find the z value directly. 1.1 into 1, 1.1 plus 1.1 into 1, that is 1.1, both are now 1.1 plus 1.1, directly calculate the z value. 1.1 plus 1.1, that is 2.2. Okay, now 2.2 I got. So this value greater than threshold. Always I told you, if z value greater than threshold, this y is going to be 1. Y predicted value is going to be 1. I got 1. Okay. So error, need to find error. What is the real output? 1. What is the predicted output? Is 1. 1 minus 1, 0. So here no error. No error means no need to update no need to update. So here I can keep my words same. So 1.1 and 1.1. So after one epoch, I have applied perceptron for each training sample. Once, that means one epoch completed. Finally, I got W1 0.1, W2 0.1. So one epoch completed. This is over here. If you want to again check with this new weight, if you want to check really it is working or not, you can proceed. So here you can test for the next round. You can test. So now you see for the next round, if I take this is 0, we want to see that this weight is working perfectly or not. So you just apply here. So this is 0. You can change the weight here 1.1, 1.1. So you try that here 1.1 into your first input is 0, second input also 0. Both are 0, z value is going to be 0, output also going to be 0. First line perfect. In the second line, input is 0.01. So here, so what happened in one term, one input 1 means, so weight value is 1.1. After summation, you will get value 1.1. That is greater than 1. That means for the next round, predicted output is going to be 1. You try, this your job. Next time you see it is working perfectly. So next time for this input and with this weight, if you try, the predicted output and the real output both are same. That means whatever weights we got, that's perfectly working. Thank you for watching. Any doubt, ask me in the comment section. Thank you.